All right, we have a quiz here in just a moment, but before we take the quiz, I want to quickly review with you what general term refers to finding the number of possibilities or outcomes that exist in an uncertain situation. What is that very general term for finding all the possibilities that exist in an uncertain situation, class? Counting. Counting can also be finding the number of things that exist, but generally in our sense we're using it to refer to the number of possibilities. If possibilities can be repeated, then to count or to do counting, to find the number of possibilities, class, all we got to do is multiply. One of the ways we looked at multiplying, though, was we looked at this idea of, well, if you couldn't reuse an item, then, for instance, if you had 7 possibilities, and the next time up, if you couldn't reuse, you'd have 6, and then after that, you'd have 5, and then 4, all the way down to 1. What's that term that refers to taking a number times all the digits below it to 1 and multiplying them together, class? Factorial. How do we represent factorial? Exclamation point. And we use that factorial in a couple of different special counting situations. The one special situation involves, again, values not being repeated, but the order very much matters. The order of items chosen would make a difference. Class, that's called a permutation when the order matters. What's the formula for a permutation? Volunteer. Formula for a permutation. Brandon?
NPR equals n factorial over n minus r factorial.
There we go, that's an R, it just looks like a V. All right, and the other scenario we talked about was a combination, which again, combinations, you can't repeat values, but the difference is that in a combination class, order doesn't matter. And so that's going to cut down on how many possibilities exist in a situation. Someone besides Brandon volunteer for a combination formula. Abby?
NPR equals...
Well, combination.
NCR equals n factorial over r factorial and then times n minus r factorial.
There we go. Do we really have to use these formulas though, class? No, because all of us have a calculator that does all of that for us. So again, the strategic key here is you pick and choose which method. Do we just straight up multiply to find our total possibilities? Do we use a permutation or do we use a combination? For instance, let's suppose a bike shop sponsors a race between 8 cyclists. And the top 3 cyclists are going to win a brand new bike of their choosing. Okay? You place in the top 3, you get new bike. How many different groups of cyclists could be winners? 8 cyclists in the race, the top 3 are going to get a new bicycle. How many different groups of winners could there be? Maddie? No. Genesis? 56. Why? What did you have to do?
I did permutation because of...
You did?
No, I didn't.
You did combination. Maddie did permutation. Why a combination, not a permutation?
Because the order doesn't matter who comes in.
Right. If it's just top 3, then it doesn't really matter who's first, second, third, right? It's just, hey, top 3 win the prize. So as you're racing, it's like, well, I'm in first, but I'm going to keep trying hard because I don't really have to be first. I just got to not be fourth, right? It's like, how do you, you don't have to be able to outrun a bear. You just have to be able to outrun your friend. Right? You heard about the ladies? There was an old lady and she and her estranged husband, they were about to get a divorce. I certainly don't condone divorce, but with her estranged husband, and suddenly they see a bear, and she saved her life with a single shot from a .22. She shot her estranged husband in the knee. That's all it took. She got away. Anyway, don't shoot the bear, shoot the friend. Former friend. Okay, anyway, I'm kidding. I don't advocate that. Anyway, let's suppose, same bike shop, sells customizable bikes. And there are 3 different parts of the bikes you can customize however you want in 8 different colors, okay? So you could make the main frame of the bike, or the handlebar grips, or the tires of the bike, okay? They sell them in 8 different colors. How many different bikes can this bike shop sell? So 3 customizable parts, the frame, the tires, the handle grips. There's 8 colors for each part. How many different bikes does the shop sell? Do you want redemption, Maddie? She doesn't want redemption. That's not a good sign. Michael?
512.
512. Why? What do we do?
Because you multiply 8 by 8 by 8.
Right, just because the frame is one color, let's say it's blue, doesn't mean the handlebar grips couldn't also be blue. Now they kind of blend in, but I mean, it could be the same color, right? You have it all black, whatever. So yeah, 8 times 8 times 8, 3 parts, each one becomes an 8. Let's suppose that the bike shop sponsors that race, but this time instead of free bike, maybe first place gets a free bike, second place gets tires for life, and third place gets their tires inflated. And after that, and maybe their money back for the entry fee. I don't know, whatever. So first, second, and third win different prizes. Now at your seats, how many different ways could first, second, and third prizes be awarded? If there's 8 cyclists in the race, that's an important detail. Brandon's looking at me like, we're missing something. 8 cyclists in the race, first, second, third, and Maddie, I know, has the answer this time. 336. This time it is a permutation because
you have they can only be a certain order.
Right, the order matters now. The order is different. First, second, third for Bob, Joe, and Joanna is different than, Joanna, Joe, and Bob, or whatever the names were I said a second ago. All right, questions on those? All right, clear desk except for a clean sheet of paper, a pencil, and a calculator. And pray that the battery of your calculator does not die mid-quiz. That would be a tragedy. Clean sheet of paper, pencil, calculator. First and last name at the top of your paper along with today's date, which is 4/26/22. 4/26/22. Do not rush through this quiz. Think carefully through this quiz. Read each problem carefully. This is quiz 34. Quiz 34. Numbers 1 through 7, fairly straightforward. Answer the questions. Numbers 8 and 9. There's 3 different ways you could do those, but I assume you're going to do it the easy way for 8 and 9. Don't let those be hard for you. For 10 through 16, take your time. Strongly urge you show your work. Just in case you have a calculator entry error, if you came up with the appropriate method, I would want to be able to give you most of the credit back. So think carefully through each of these. Do not rush. I'm going to stop the video here. We'll pick back up after the quiz.